Hello, welcome back to Oracle DBA tutorial. In this tutorial, we are going to discuss about 4 different background processes. And from our last video, we discussed that our database which we are running right now is configured with all this kind of different processes, and we have already discussed by this time the system processes like recoverer, PMON, SMON. In this set of videos, we are going to discuss on checkpoint, log writer, database writer, and then archive log file. So that is, first is checkpoint, second one is DB writer, third one is log writer, fourth one is archiver. So we need almost, whenever we explain the scenario, we're probably going to introduce all these 3 processes at one go, at one time. Okay, and so let's go on and check something, what is important. So what is checkpointing? Sorry, checkpointing. Okay, so what is the checkpoint concept that we need to understand first? So let's consider our database a simplified diagram of whatever we drawn before. So this is our SGA, and SGA consists of different types of pool, but for simplicity what I'm going to do, I'm going to consider only 2 things. One is my database buffer cache, and the second one is redo buffer. Okay, and then what I have my the file system here. So this is the file system, and as I know, in file system are different types of files, but for this example, I'm just going to assume that I just have only one data files and online redo files, and this is my data files. Let's say I have multiple of them, so let's file 1, file 2, another file like this, file 3, and so on. Whereas I also have my online redo log files, and let's say this is my online redo log files, and then they are minimum 2. So assume that I have just only 2 redo log files, R1 and R2. Okay, so this is the scenario. This is a very simplified scenario of my database, system global area, the memory structure, and the file system. So let's say somebody is inserting a row to this database. So let's say one user is submitting insert into employee and then some values. So when this insert statement comes to the dedicated server, and dedicated server is going to parse this thing, and then what's going to happen, it's going to modify the buffer cache with the new value, whatever the value that we are inserting. At the same time, Oracle is going to put enough information on the redo buffer so that it can redo this insert again. In case of some failure or something, it can redo this insert again. So therefore, what we are going to modify the redo buffer. So the redo buffer is going to keep the change vector that is required to redo this insert in case of some kind of failure or some kind of things. Okay, fine. So this is this is what is going to happen. The first, remember that is not going to be, so basically let's say here is the employee table. So employee table information is stored in the file F1, and let's say department tables information stored in file F2. So in this case, when I'm going to do insert, nothing is going to be written into the F1 or F1 file or employee tables file system. Okay, just only the change is done here in the buffer cache, and that's it. Let's say another guy is going to do another insert, then same thing is going to happen. For the second insert, I'm going to modify something in the buffer cache, and by the way, these buffers are called dirty buffers because they are written something on top of that, right? So basically dirty buffers, and then I'm going to also have some information in redo so that I can redo this insert. Let's say after that this guy is going to do a commit. So when this guy is going to do a commit, then what's going to happen? There is a process. That process name is called log writer or LGWR. Okay, so log writer is going to write whatever is available in the redo buffer to the current online redo log file. Let's say the current online redo log file is R1. Okay, so in that case, what's going to happen? The redo log file is going to write those information into this log file, and then these things are right now, there is no, these things are clean right now. Okay, there is no more is there. But however, if you notice that we have not written anything from the buffer cache to the actual table. Okay, so this is, and whatever we are storing, we are not storing the data, we are storing enough information so that we can redo this to insert again. Okay, so those information are stored here. So after that, somebody else is going to insert into department table. So again, like, this thing is going to be changed here in the redo buffer, in the database buffer cache, and also I'm going to have some information here also in the redo log file. And eventually, this will keep going, and then if somebody do a commit, then again something is going to be written here to the redo log file or to the online redo log file. So from the redo buffer writing to the online redo is quite frequent. Okay, but however, still, like, I have some data buffers there, and then still there is no no data here in the data files F1 or F2. Then let's say it reaches some sort of threshold. So in that case, when it reaches some sort of threshold, that means, let's say, like, database buffer cache is completely full. Is full, then if now it is completely filled, then it's not going to be, no one can write anything anymore, right? So in that case, what is going to happen? There's another process, and that process name is called DB writer. Okay, so database writer is going to write the dirty buffers, whatever available here in the buffer cache, to the data files. See, for example, like, these two buffers may be for employee table, which is stored in the F1 file, and these two may be for department table, which is stored in the F2 file. So in that case, when database writer is going to write, it's going to write to F1, and also it's going to write to F2. Okay, so depending on where this buffer is supposed to go, it's going to put there. And then so this is how it's going to happen. So the process of writing the dirty buffer to the from the buffer cache to the file system is called checkpointing. Okay, so checkpointing is an event which says that, okay, write the which indicates to the database writer, write from dirty buffers from the buffer cache to the data files. Okay, so that's, when this write this thing, the CKPT process, which is the checkpoint background process, what it's going to do, it's going to generate a unique number that is called SCN or system change number. And then checkpoint CKPT process is going to go to all the data files where the DB writer just written, go to the header, and then put this SCN number there. Let's say this SCN number generated is 101. So it's going to go and then modify this header to 101 and this header to 101. Nothing is going to happen to F3 because DB writer has not written anything to F3 file. Okay, so remember, checkpoint, what it is going to do, it is going to go to the files where DB writer just written data, and then it's going to update the header with the system change number. Don't worry why it does. It does for a purpose, and we are going to explain those things in detail and with a detailed scenario when we are going to discuss about recovery, backup and recovery. Okay, so here is important thing to understand. CKPT or checkpoint process is not going to write the buffer. The buffer cache, the database buffers is going to be written by the DBWR process, not by CKPT process. Okay, so that is one thing that you need to understand. CKPT is just going to do update the headers. Actually, before Oracle 8.0, okay, so before Oracle 8.0, there was no CKPT process. Okay, it was the log writer who is going to go and modify all these different headers. But as the data as the data file grows, it might take a long time if we use the log writer. Okay, so therefore they comes up with a new process called CKPT, and then CKPT is going to do the job what log writer used to do before Oracle 8.0. Okay, so I hope you understand the checkpointing concept, and you understand what exactly the CKPT does. Now let's, and then we also introduced you three other processes, DBWR and LGWR. Okay, so the two other processes, DBWR and LGWR. So let's do a detailed analysis about DBWR. So DBWR essentially is going to write, so let's assume that this is your buffer cache, DB buffer cache, and then this is your data files. So as I told you, like these are the data buffers because of some insert or update or or even delete or whatever. And then database writer, what is going to do, it is going to collect all these data buffers and is going to write those things to the data file. So actually it is not really going to write them to the data files. It collect these buffers and then give it to the operating system, or there is a slave process, and give it them that okay, so go on and write it to the data file. It does not. DBWR, it does not go and then write itself. It is going to depend on another slave process, or it is going to outsource that work of writing to the data file to a slave process. And then in the meantime, it is going to come and then look at what are the other data buffers is going to be eligible to be written. This is why this is called async IO. So async IO means the database writer does not wait to see if actually this buffer whatever he has given to the slave process is really written or not. The number two characteristics is called scattered IO. So that means, as I told you, like this may be this buffer cache changed for employee table, and this buffer cache changed for a department table. So what happens is that maybe this employee table there in one disk in a data file, and department table maybe reside in another disk in the data file. Okay, so these are two data files. This is file 1 and file 2. It may happen that I might have multiple disks in my server, and then one is whenever I'm writing. So my point here is that when I'm writing this 4 buffer cache, it may happen that I may write in two different disks, and that is why it's called scattered IO, and that is why it is slow, because it needs to write in multiple different disks. Okay, so the number 3 point that I want to make is that a lot of time people you can configure, so let's say for example if you have a lot of database buffer cache and all these things, to make it parallel and make it faster, what you can configure multiple DB writer, which is called DBWR 0, DBWR 1, and so on. You can probably, I think if I remember correctly, you can go up to 36. So you can configure 36 DB writer. But before you configure 36 DB writer, just make sure that by increasing DB writer, your performance will increase. What happens sometimes, people might have just only 2 CPUs, they are running the database, or whatever is in this in that case. In that case, if I'm going to have 4 DB writer, it's not going to help, because the maximum number of CPUs I have is 2. So therefore, by increasing DB writer just abruptly, it's not going to help. Rather, it might worsen your performance. Okay, so be careful about that. So this is all about your database writer, and then let's next go to the next process that we discussed, log writer. So here, in case of log writer's job is going to plus this is a redo buffer, and this is in SGA, and then you have in the file system you have so let's draw this thing properly. So in the file system you have online online redo log. So as I told you, there are two always online redo logs comes with pairs, so either 2 or 3 or 4 or so on. Okay, and there's a reason for that, and I think I have already explained that one in the previous videos. So when this something got changed here in the redo buffer because of that insert, log writer, the process is going to write those things to the online redo buffer. Log writer is going to write on the following 3 circumstances. Number 1 is in every 3 seconds. So in every 3 second log writer is going to write. Number 2 is that whenever somebody does a commit, when a commit happens, log writer is going to write from the buffer, basically plus everything from the buffer cache to the online redo log. And the final thing, number 3, is when this redo buffer is 1/3 filled or 1 MB filled, whichever is faster. Okay, so under these 3 circumstances, log writer is going to write from the redo buffer to the online redo log file. One point you may understand here is that this log writer is always going to write to one file. Okay, so unlike your database writer, where we have different blocks from different tables which lies in the different which can be in different file system, even in different disks. So therefore in DB writer is a possibility that it's going to write to different disks, but in case of log writer, it's pretty sure that it's going to write to this redo log file R1. So when this redo log file is filled or whatever happened to the online redo log file, is going to switch to the next one. So that means in case of log writer, it's going to be faster. Okay, so it's a sequential write, and then we know to which redo log file is going to write. And another thing is that redo concept is important from the recovery point of view, like your instance crashes or your media recovery and all those things. So in that case, what we need to do, we need to make sure that we protect these datas. Okay, so therefore we always store this online redo. So this file will be always stored in a faster disk, where we can write quickly. Okay, so if we do that, then this log writer is going to write those things quickly. Okay, the next thing is that archiver process. Okay, so as you see that we have so let's go back to the main picture. So this is how, so log writer writes to from the redo buffer to the redo log files. Let me just choose a good color. Okay, so log writer is going to write to the redo log file, and then when this redo log file is going to completely filled, then it's going to switch to the next redo log file. And let's say we have just only 2 redo log file, and then let's say eventually this redo log file 2 is going to be filled, and when redo log file 2 is going to be filled, then it's going to come back again to the redo log file 1. That means redo log file 1 is going to be rewritten. So before redo log file is going to be rewritten, what we can do, we can use another process called archiver, and then we archive all this information to a offline storage, and we need those things in some special circumstances of database backup and recovery. Okay, so we will explain you on detail, like when you need this archive storage. Okay, but it's one thing, just remember, it's important to before we rewrite the redo log file, keep those things, the old things, to a archive storage. And the process that is going to write from the redo log file to the offline storage is called archiver process. Again, depending on how many number of redo log files you have, you can configure multiple archiver. Again, it depends on your database, your circumstances, your workload, and all this thing.